Welcome. This is Finance Cottage presentation on exponential constant. In this video we shall discuss how the value of exponential constant evolved and how to use it. To understand the evolution of the value of exponential constant, let's take an example. Suppose we have an initial amount of money equals to $1 and we want to know what would be its future value after 1 year if we invest this $1 at compound interest rate of 100%. In that case we need to apply the formula of future value, which is equal to future value equals to present value multiplied by 1 plus interest rate raised to the power n. Now if we put the value of interest, which is equal to 1 in this case, and the duration n is also 1 year, the future value of $1 would become equal to 2. So this is a simple case where we are compounding the interest rate once in a year. Now what if we compound the interest semi-annually? So in case of semi-annual compounding, we need to introduce another term which is known as frequency term, which represents the number of compoundings in a year. We denote this frequency term with small m, and in case of semi-annual compounding this would be equal to 2. Because in semi-annual compounding the interest is compounded after every 6 months, which means that in 1 year the interest would be compounded twice. So in that case the future value would be equal to present value multiplied by 1 plus interest rate divided by the m and the duration multiplied by with the m. Now in this example we know that the interest rate is 1 and m is 2 and duration is 1 and m is 2. If we put the values of interest, duration and the compounding frequency, the equation would look like the future value equals to present value multiplied by 1 plus 0.5, because 1 divided by 2 equals 2.5, multiplied by 2 because n is 1 and m is 2. So in that case future value equals to present value, which is 1 multiplied by 1 plus 0.5 raised to the power 2. Now by solving this equation we can calculate the future value of $1 in case of semi-annual compounding equals to 2.25. Now if we increase the frequency of compounding, means if we want to know what would be the future value of $1 if the interest rate is compounded quarterly, or if the interest rate is compounded monthly, or maybe with a higher frequency like daily compounding, or maybe a more higher frequency, what would be the future value of $1? So to understand this concept, let's make a table. Now in this table the first column shows the frequency of compounding. In case of annual compounding the interest is compounded once in a year. In case of semi-annual compounding the interest rate is compounded twice in a year. In case of quarterly it is compounded 4 times in a year. In case of monthly it is 12. In case of semi-annual it is 24. In case of weekly 54, and so on. If we want to know the future value of $1 at compound interest rate of 100%, which is compounded annually, semi-annually, quarterly, monthly, semi-monthly, weekly, daily and so on, what would be the future value of $1 after 1 year? So in that case we need to put the formula of each of all these cases. So I've done this for you. The formulas are future value equals to present value multiplied by 1 plus interest rate divided by m and raised to the power duration multiplied by m. So in case of semi-annual compounding the interest rate is divided by 2 and the duration is multiplied by 2. In case of quarterly the interest rate is divided by 4 and duration is multiplied by 4. Similarly in case of monthly it is the interest rate is divided by 12 and duration is multiplied by 12, and so on in all these cases. So what is the future value in case of annual compounding? In case of annual compounding we have already calculated the future value equals to 2. What in case of semi-annual and quarterly compounding? In case of semi-annual compounding the future value of $1 would be 1.25. In case of quarterly it is 2.44, and in case of monthly compounding you can see the value of $1 equals to 2.613, and semi-monthly 2.66, and again 2.69 for weekly. For daily it is 2.714, for hourly it is 2.718. In case of every minute, it is 2.718. In case of every second, it is 2.718. Now from this demonstration you can get a very interesting idea that as the frequency of compounding approaches infinity, the future value of $1 is approaching to what? It is approaching to a fixed value which is equal to 2.718, and this 2.718 is the value of exponential constant. Exponential constant actually represents the continuous compounding concept, where the interest is compounded infinite period of times in a year. So to represent the infinity, you can yourself see that as we reaches infinity, the future value of $1 reaches to 2.71828. So this is the concept behind the fixed value in case of continuous compounding, and this value is represented by small e, and the value of this small e is 2.7182. Now to calculate the future value in case of continuous compounding, the formula is future value equals to present value multiplied by exponential constant, whose value equals to 2.7182 raised to the power interest rate multiplied by the duration n. So if you want to know the future value of any amount of money for a given period of time at a given interest rate compounded continuously, you can apply this formula and you can calculate the future value. Now for example, if the present value is $850 and you want to know the future value of $850 after 1 year at a compound interest rate of 12%, and it is compounded continuously in a year, so what would be the future value of 850? By applying the formula, future value equals to present value multiplied by exponential constant raised to the power interest multiplied by n, you can calculate the future value of $850, which would become equal to $958.3723. So if I put in this value here, the initial amount equals to $850 and the interest rate equals to 0.12. So you can see that in this table shows that the future value of $850 at a compound interest rate of 12% compounded continuously in a year, the value is approaching to a fixed value which is 958.3723. This is because we are using a fixed value of exponential constant 2.7182. So this is the idea behind the fixed value of exponential constant, and it is used where interest is compounded continuously. Now look at this graph. This shows that as the compounding frequency approaches infinity, the future value of $1 is approaching to a fixed value which is equal to 2.7182. So this is the concept of fixed value of exponential constant. Now the question is how to use and when to use the exponential constant, or when to use the continuous compounding concept. Normally the continuous compounding concept is used in financial derivatives, like derivative securities like options and futures, etc. But in this video I'm going to give you a very simple example of using continuous compounding concept. For example, the present value is 1000 and the future value is 1500, and the duration is 1 year 9 months, and we want to know the annualized rate of interest at which if we deposit $1000 for 1 year 9 months, they would become $1500. So to calculate the annualized rate of interest where duration is 1 year and 9 months, and we have the present value and we have the future value, we can use the concept of continuous compounding. We shall apply the continuous compounding formula to calculate future value, which is equal to present value multiplied by exponential constant raised to the power interest multiplied by duration. Now in this case, future value is 1500, present value is 1000, value of exponential constant is 2.7182, raised to the power interest rate, annualized interest rate which we want to calculate, and the duration is 1.75. 1.75 means 1 year 9 months. Now to solve this equation for I, we can calculate the annualized rate of interest equals to 23.17% approximately. So this is a very simple use of concept of exponential constant, where we want to calculate the annualized rate of interest, and for a given value, for a given present value and future value and duration of 1 year and some months or some weeks or so on. So you can use the concept of, or the value of exponential constant to calculate the annualized interest rate. So this is all about the explanation of exponential constant and its use. Thank you for your time.